This is a problem from your lab assignment, section 6.3. This is problem number 2. It says to use logarithmic differentiation to find the derivative of this function, and our function is y is equal to x raised to the 7 times cosine x. So 7 times cosine x is a power. Now the tricky part about this is that there's an x in the base and an x in the power. So when we have that situation, we cannot do the regular power rule where we take this expression and move it down in front of the x and then subtract 1. That's not going to work. And it's not an exponential function where we just, the derivative is itself times the derivative of the inside or whatever it was that we used to use. So here it's something a little bit different. This requires what they call exponential differentiation. So what we're going to do is we're going to take the natural log of both sides. And I have it here in my little Word file. And so let's take this expression and then we say take the natural log of both sides. We're actually taking the ln of this expression, y, and then we're going to take the ln of this. And now when we take the ln of the right hand side, we have the ln of something raised to a power. Now one of the rules that we have for this is we could take, if we're taking the ln of something to a power, we could actually take this expression and move it as a coefficient in front so that that power kind of just disappears. It not disappears, but it actually came down here. So that is an important property for a logarithm, where we can take the expression of the exponent and bring that down as a power. So what do we have left here? We have the right hand side actually becomes 7 times cosine x times the ln of x. So they want us to use the properties of logarithm so that we can rewrite this equation after we take the ln of both sides, and that's equivalent to this expression, 7 times cosine of x times the ln of x. Okay? So now that we have that, we're going to take the derivative of both sides. And so we'll focus on the derivative of the right hand side first. And 7 times cosine x times ln x is a product. We can actually consider this as one function, the 7 times cosine x, and we'll consider the ln of x as another function. So the product rule says we're going to take the first term and then now take the derivative of the second term. That's 1 over x. Plus the second term here, and then the derivative of the first term. So 7 is a constant. We'll keep the 7 there. The derivative of cosine is negative sine. So that is going to be our derivative of the product. So that's the right hand side. Now the left hand side of the equation we're looking at is ln of y. Now ln of y, if we want to take the derivative of that, we're actually going to use what's called implicit differentiation, because y is originally a function of x. So the derivative of ln of y is going to be 1 over y, because it's an ln function, times the derivative of the inside of the ln function, which is just y. And so they have that provided for us. That's y prime. So the derivative of the left hand side is going to be 1 over y times y prime. Now we want to solve for y prime because that's what we're looking for, and now we're going to essentially bring this y on the other side. So we're going to replace y with this, but before we replace it, I just want you to see how it's going to look like. We're going to have the right hand side is going to be this whole thing. Let me do this in pieces first, the way I would think about it. 7 times the cosine of x divided by x plus negative, so that's just going to be a minus 7 times the ln of x times the sine of x. Now this whole thing is this right hand side when the left hand side is y prime over y. So what we're going to do is we're going to multiply this side by y. Unfortunately, the y is not in terms of x, but if we look at our original problem, the original problem says y is equal to x raised to the 7 cosine x. So we're just going to replace this with x raised to the 7 times the cosine, cosine, there we go, of x. Okay, so this is the y that we have. This is the derivative of the right hand side after we took the ln, and so we're going to solve for y prime by multiplying y on both sides, but then we have to replace y with the original expression. So this should be our final answer, and now we've taken the derivative of all that. Okay, hope that helps.